Alright, welcome back guys. This week will be part 2 video of 3.3. We talked about z-score measurement in the last video, and that is just given a value of x from a data set, we can take that data value and discuss how far that data value is above the mean or below the mean by looking at the number of standard deviation, and that itself is a z-score. So a z-score is just referred to the number of standard deviation of a given x value is whether above, below, above the mean. We look at several examples and show how to use the formula and discuss what the answer interpretation would mean. And now we look at another measure of relative standing is called percentiles. So percentile probably the more common measurements or terms that we often hear in daily life in z-scores. So in this, so the definition is the way we define percentile would be measurements of position or location. Okay, so measures of location or position. Okay, and then it's often denoted by p sub 1, p sub 2, p sub 3, all the way up to p sub 99. So we take a data set, we plot the data set, scale the data set, the data values, and then we can divide that data set into 100 percentile. Each percentile is 1% of the data values. So P99 is the 99 percentile. So which divide a set of data into 100 group with about 1% of the values in each group. Okay. All right, so let's look at an example. Okay, when we hear percentile, suppose a newborn baby measuring 21 inches long and was reported to fall at the 93 percentile for length of all newborn babies. What does this result indicate? Okay, so imagine all the newborn babies. Look at that data set. Has, each baby measures certain inches long, and we're looking at the entire data set. Okay, suppose your newborn baby measures 21 inches long, and that is at the 93rd percentile, and we want to interpret what that means. In other words, is that something that we can describe and make sense of people, or it's probably probably the most accurate way and fast way to describe something for a large data set, but it may not be as straightforward for some of us to understand what 93 percentile means. So in this example here, what we can say, there's more than one way to interpret it, as long as the wording is somewhere along the, saying what the 93rd percentile represent. So we can say that, this result here indicates that this newborn baby measuring 21 inches long, measured 21 inches is longer, right? Longer than 93% of all newborn babies. Okay, that's exactly what that means, a 93 percentile. So imagine here's a scale, all right? We're looking at 0 to maybe 50 inches for the length, right? And then maybe here's 25, half, actually, yeah, that's 25, and then 21 is here. Let's say here's 21. So imagine all the newborn babies, most of them are scattered around here, right? All the length is right here. somewhere there, and then just a few in the up this area, right? So let's say your baby is probably somewhere right here, and that's about more than 93%. Or we can say, this newborn baby. Another way of saying this is this newborn baby is in the top, uh, 8%, 7%, in the top, 7% of all newborn baby, right? So we can look at that way. We can either say longer than 93% of all newborn babies, or in the top 7% of all newborn babies' height or length, right? Or length. So that's one way of using percentile there, right? The rest of this video, the rest of this lesson, kind of go through the mechanics, how to take a data value from a set and then assign a percentile to that. Or, given a data set value, we want to identify certain percentile that correspond to what data value. Meaning, suppose someone got a score of 1900 on the SAT score, and say, okay, well, how do I compare myself to the rest of the students who took the SAT score this year? What percentile am I in, right? So that's one way of using percentile, is given a score, convert that to percentile, make that to a corresponding percentile that compares to the rest of the data set. Or we can, take the percentile, find the data value correspond to a particular percentile, meaning what SAT score is the cutoff value, cutoff percentile from the 90 percentile to the top, 90 percentile or the top 10%, something like that, right? So kind of two way of using percentile. So that's what these two last thing we're going to talk about here. Kind of boring, it's kind of confusing too, but it's good to kind of good to run through one time and kind of see how you do by hand. But realistically, if you're looking at a data set that is a million data points, doing this by hand is not the way to go, and that's why we have technology. So, but I still want you to see how would you do this by hand at least one time, so you see the point. The easiest one for finding percentile is the median. So suppose we're given this sort of data, and we want to describe these numbers relative to the set in terms of their position, the percentage. So we got 3, 4, 6, 8, 10, 12, 13, 13, 15, 17, 20. So this is the data set. So this is 100% overall, right? So we got 6, and then we got 12, and then we got 15, right? So how many data values are there? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 data values. So 12 is exactly in the middle. So this is the median. It's been ordered. And then the median, we can say that's the 50 percentile, right? And then from here, we can say this is the, so if this is 50, that means in the middle, 6 is in the middle between those. So that is 25 percentile, right? So roughly the 25 percentile, or P25, right? And then 15, we can do that P75. Okay. All right. So let's start with this one here. To find the data value that corresponds to a particular percentile. Okay, let's start with that one. To do this, we compute the value of the located L, or the number of data values fall within the bottom K percents, given by the formula L is equal to K over 100 times N, where N is the total number of data values. Step 2, if L is not a whole number, we round up instead of round off, and then count from the lowest to the sorted data. in the sort data to the new round number L, the result data value corresponds to K percentile piece of K. If L is a whole number, we take the average of the data value that corresponds to L, and L plus 1, count it from the lowest. The result of our answer is piece of K. That was a lot of reading just to convert this whole thing. So it's a bit of a mess. It's confusing to follow, but here's what we do. If we want to find the data value that corresponds to P40, so P40 is what data value? That's what we're asking to do. Here's how to do it. All right. First, we find the L. So L is the locator. It is K over 100, which is the 40 over 100 percentile, times N, sample size, or the size of the data set. So that's 3, 6, 9, 10, 10. So that is for 100 divided by 100, which is 4. So L is a whole number. Okay, so L is indeed the whole number. Okay, we're going to take the average that data value corresponds to L and L plus 1. So we do 1, 2, 3, 4, and then 5 there. So we take the average of those two. So 8 plus 10 over 2. So that's 18 over 2, which is 9. So 9 would be our 40 percentile. Okay, so P of 40 corresponds to data value 9. Okay. All right, 72. So a locator is 72 over 100 times 10. So what have we got? We got 720. 720 divided by 100. So L is 7.2. It said if L is not whole number, round up instead. So round up to 8. And then we count. We got 1, 2, 3, 4, 5, 6, 7, 8. So 15. So we can say 15. So P of 72 is roughly 15 is the data value. So we say 15 is the 72 percentile. So X value 15 is at the P of 72. So 72 percentile. Now going the other way, finding percentile of the data value. The process of finding a percentile that corresponds to a particular data value X is given by the following formula. So this is saying, given a data value, what percentile that is. I mean, if I point to 17, what percentile is. If I point to 4, what percentile that is compared to the rest of the data value. Okay, so this is how we do it. 4, let's do 4. 4 is at what percentile? Okay, let's do that. To do this, so we said a number of data values less than X. So that's 1. Total number of values, which is 3, 6, 9, 10 times 100, which is going to be 10. So we said 4 is at P10. 17, so at what percentile? So first we count how many numbers less than 17. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Less than, not equal, so 8. So 8 numbers less than 17 out of 10 times 100. So that means 80. So 17 is at P of 80. Okay. 5 number summary at box plot. And those are P1, so that would be min, Q1, Q2, Q3, and max. So Q's are quartiles. So Q is the P25, Q2 is P50, Q3 is P75. Those are quartiles. So any data set we can quickly sketch based on these 5 number summary, which will create a box plot. So what we can do here is we can say in this data set we can graph a box plot. We can say min is 3, max is 20, Q1, Q2, Q3. Okay, so I'm gonna say Q3 is 3, 5, 3, 5. So 1, 2, 3, 4, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 numbers. To find the median, to find Q2, the median would take the two middle value numbers and average them. So which is these two, 10 and 13. So we said 10 plus 13 divided by 2 is how many? 23 divided by 2, 11.5. Q1 is 6, Q3, 2, 3, 4, 5. Q3 is 15. So these are the 5 number summary. Min, max, 25 percentile, 75 percentile, 50 percentile. So now we can we can graph a box plot. Okay. So we first draw the scale, a number line. We label it. We say min, so let's say here's 0, 5, 10, 15, 20. The min in this case is 3. Here's 3. And then max is 20. And then median is 11.5, so maybe here. It's median. Q1 is 6. 6 is right there. Okay, and then Q3, 15 is right there. Okay. And then we're gonna connect this mailbox. And there it is. That's our box plot. Okay, so that's min, max, and then Q1, Q2, Q3. So we can actually tell the distribution of the data set based on the box plot. As you can see how the boxes kind of skew a little bit to the left. Notice that if you look at up to this point here, this is 75% data, so majority of the data value is on this side. So that's if that 75% of the data, and this right here, this longer stretch here is 25%. So we can say that this distribution is sort of right skewed with the longer right tail. Okay, so that's one of the main application of box plot is being able to recognize the distribution of the data set, and it's very useful when we compare across data from different group of data set there. So here's what example 8 is referring to. I can certainly do this on Zoom here, but I'm going to pause the video on this note here.